Dear students, welcome to the fourth class on circles of 10th standard mathematics. Today, we will discuss a special property related to chords of a circle. When two chords of a circle intersect at a point inside the circle, there exists a special property. We will derive that property at first. Then, we will apply that property in some constructions, such as drawing polygons having equal area to a given polygon. And so, at first, let us derive that special property. See, in the figure, two chords of the circle AB and CD meet at the point P. We have to prove PA into PB. That means the product of these two pieces PA and PB is equal to the product of the pieces PC and PD. Mean we have to prove when two chords of a circle intersect at a point inside the circle, the product of the pieces of each chords. That means here PA and PB are the pieces, and then their product is found. It will be equal to the product of the two pieces of a other chords. That means PC into PD will be same as that of PA into PB. Okay, let us prove that one first. For this, first let us join AC and BD. First we join AC and BD. See, AC and BD are joined. Now let us, when we write the answer, let us write that step at first. We joined AC and BD. Now let us consider triangle APC and triangle BPD. On considering that two triangles, when we consider these two triangles, we see angle A is equal to angle D. That two angles are equal. Why that two angles are equal? That two angles are angles made by the arc BC at its alternate arc. Hence they are equal. We have already said it and proved it. Okay. And so these two angles, angle A is equal to angle D, as they are angles made by the arc BC at its alternate arc. In other words, they are angles in the same arc. Like that, angle APC and angle BPD, these two angles are also equal, that two angles, because they are opposite angles. When two lines intersect at a point, we see their opposite angles will be equal. We have proved it in the smaller classes. Okay, therefore angle APC equal to angle BPD. Now we have come to tell like this. This triangle gets two angles equal to two angles of the other triangle. That is enough to tell two triangles are similar. We can tell these two triangles are similar. See, this symbol represents similarity. Okay, when two triangles are similar, mean one triangle will be the photocopy of the other, or it is an increased or decreased size of the other. Same shape is there, but their sizes are different. Now we can tell it like this. When two triangles are similar, let us tell it their sides are proportional. Proportionality of the sides mean the ratio between two sides of one triangle will be same as that of the ratio between corresponding sides of the other triangle also. Okay, that means when we take AP, it is the side against to the unmarked angle there. Like that, the unmarked side against to the unmarked angle here, it is PD. Therefore, AP, when we consider AP, the corresponding side is PD in the other triangle. When we consider PC, it is the side against to this marked angle. There the side against to the same marked angle, there it is angle D, its opposite side is PB. Therefore, when we find the ratio between AP and PC, AP by PC will be same as that of PD by PB. The proportionality of sides mean we can write their side ratio of the sides will be equal, and so we write it like that. The proportionality of sides, this one is the another version for proportionality of sides. That is PA by PC equal to PD by PB. Now PA is the numerator and PB is the denominator of the second ratio. Therefore, PA into PB on cross multiplication, PA into PB will be equal to PC into PD. That we are asked to prove. That means when we multiply PA by PB, the product of these two pieces is same as that of product of these two pieces. That means when two chords intersect inside a circle, the product of the pieces are equal. Here we get a very important result. Let us write that one in a box. When two chords intersect at a point inside the circle, then the product of the pieces are equal. That means what product is there when we multiply these two pieces, the same answer will be there by multiplying these two pieces. Okay, this one is very important. You have to write this question there, this figure there, then these much steps to come to this result. At last this result should be put it in a box. Here this result we will apply to construct a rectangle with the area equal to a given rectangle. See, if a rectangle gets its length this much distance PA and breadth PB, its area will be PA into PB. If another rectangle is to be drawn with the same area, we need only to make its length and breadth equal to PC and PD, so that PC and PD are different from PA and PB, but on multiplying PC into PD, that means its length and breadth will be same, or that is its area will be same as that of the other triangle also. And so we have to draw such a rectangle with the area equal to a given rectangle. Before drawing such a rectangle, first we need to know a special theorem that you have learned in the, or you know how to construct a circle as passing through three vertices of a triangle. You have to get a prerequisite that you have learned in the 9th standard, how a circle can be drawn as passing through three vertices of a triangle. If three vertices are given, if 3 points are given, how to draw a circle as passing through them. Let us just recall how that method. Here it is needed to construct for the construction purpose. See, here a triangle is given. Now we need to draw a circle through these three vertices. Now when such a circle is drawn, we see at that time this chord, this line, this side of the triangle will be chord of the circle. Therefore the center of the circle must lie on the perpendicular bisector of that chord. Mean the center of the circle must lie on the perpendicular bisector of this side of the triangle. Let us first draw such a perpendicular bisector to this side. Okay, for that keep compass here. Keep compass here. Take a particular distance in compass. It should be more than half of the total distance. Okay, keep compass here. Extend compass as more than half. Draw an arc here and here also. When you draw such two arcs, it will be like that. See, you will get two arcs drawn. With the same distance in compass, keep compass here. Draw another two arcs to cut the first two arcs. You will get such two arcs. See, when we see here an intersecting point of the arc is there, here and also an intersecting point is there, we have to join that two intersecting points. We will get it is the perpendicular bisector of one side. We can do the same process. Let us repeat this activity for other side also. Keep compass here, take more than half, draw two arcs to both sides. We will get such two arcs there drawn to two sides. Keep compass here, draw another two arcs to cut that two arcs. We will get such two arcs. Now the intersecting points are joined. We see we will get another perpendicular bisector of the side. Okay, to the circle, this one is a chord, therefore the center of the circle must lie on its perpendicular bisector of the chord. Like that, this one is also a perpendicular bisector of the chord which we are of the chord of the circle which we are going to draw. Therefore the center of the circle must lie on this perpendicular bisector, and this perpendicular bisector mean it should be at the meeting point of the perpendicular bisectors that we have learned in the 9th standard. Therefore the meeting point of the perpendicular bisectors determine the center of the circle. Now we have to keep the compass at that point and extend the compass to any one of the vertex. Then start rotating. Definitely a circle will pass through that three vertices. In this way, we know to draw a circle to pass through three vertices of a triangle. Okay. Now let us construct a rectangle at first. Then another rectangle is to be drawn with the area equal to that given rectangle. Let us have it done. See. Here, a rectangle is given. Its length and breadth is not measured. We have to draw another rectangle with different length and breadth, but its area should be same as that of this given rectangle. How it can be drawn? For that, let us first redraw the rectangle. Let us name the rectangle by A, B, C, D. See. Now, area of this rectangle is now AB into BC. To get another rectangle having the same area as that of this one, let us determine how much distance, what should be the length for the next rectangle. We can give any length, any measure as the length for the next rectangle. Let this much length we want to give as the length of the next rectangle. Okay, that length is drawn through the vertex B. Now we can draw such a length in any direction, and we have drawn, let us name the end point by H like that. Now BH be the length of the rectangle to be drawn. Now its length is there. We have to determine how much is its breadth. To determine that one, let us first extend AB outward. AB is extended out. Now on that extended line, let us mark a point such that the distance to that point from B should be same as that of the distance from B to C. For that, we have to keep compass here at the vertex B. Extend the compass to C. Now, keeping the distance in the compass, draw an arc here along this extended way to cut that extended line. We will get a point there. That point let us mark, and that point is named. Let us name it by E like that. See, now BE is equal to BC. Now let us draw a circle through the vertices A, H and E. We will explain for what purpose such a circle is drawn. We have to draw a circle through the vertices A, H, E. We have explained how a circumcircle to a triangle is drawn. That you know, that you have learned in the 9th standard itself. Here a circle is drawn through the vertices A, H, E. Then it will be such a circle. Say, when a circle is drawn, it will pass through that three vertices. We can draw a circle passing through A, H, E like that. Now to that circle drawn, AE is a chord of the circle. And if we could draw another chord cutting that chord to the vertex B, passing through as or by extending BH, we will get two chords intersected at the point B. See, here the area of this rectangle, the initial rectangle is AB into BC, or it is now AB into BE. Now if we could draw another chord by extending BH to cut another point on the circle, we get two chords intersected at a point. Then the product of the pieces of the chords are equal. That we have proved. Using that method, we can complete the rectangle then. Okay, for that let us first extend BH outward. When BH is extended, it will meet at a point on the circle. See, here let us extend BH. It will meet at a point on the circle. Let us name it by I like that. See, Now we see the chords AE and HI intersect at the point B. BA into BE gives the area of the rectangle ABCD. Now we have proved when two chords intersect inside the circle, the product of the pieces are equal. Therefore, that product will be equal to the product of BH and BI. That means BH into BI will be same as that of BA into BE. And so, if we could draw a rectangle with length BH and breadth BI, that rectangle also will get the same area as that of the initial rectangle. Then the only thing with us is to draw a rectangle with length BH and breadth BI. And so here let this be the length. We have to make here breadth. For that we can mark that breadth along a perpendicular line drawn at the vertex B. Here let us draw a perpendicular to BH, a perpendicular line to BH at the vertex B. For that we have to keep the protractor here to make a 90 degree angle. See, protractor is kept there, and the one side of the protractor is attached with the line BH like that. Okay, now where 90 degree fall, put a dot. See, now removing the protractor we have to join B and H. Remove the protractor, then join B and that point got outside. Okay, then we will get a perpendicular line like that. Now this line is perpendicular to BH. Along that perpendicular line drawn, let us mark the distance BI along that perpendicular line. For this, keep compass here at the vertex B. Measure or extend the compass up to I. Keeping that distance in the compass, let us draw an arc on this towards this extended line. Then that arc will cut at a point on this extended line. That point let us mark it by like that. See, that point is marked there. Now let us name that point by F like that. See, it is F. Now BF is same as that of BI. Now if we could complete the rectangle with length BH and breadth BF, that rectangle will get the same area as that of the initial rectangle ABCD. Now the only thing with us is to draw the other two sides. For that we have to keep compass here at the vertex B. Extend the compass up to H. Therefore, keeping the distance in the compass B as that of the distance BH, keep compass here at the vertex F. Then draw an arc here. Then take this much distance in compass. Keep compass here at the vertex H. Then draw another arc to cut the initial arc. Then that two arcs when drawn, they will intersect at a point here somewhere. Let us mark that point by some H like that. No, here H is already written, and so let us name it by some G like that. See, here that point is named as G. Now let us join HG and FG so that the rectangle will have completed there. See, this rectangle, newly drawn rectangle BFGH, get its length and breadth BH and BF. It is therefore the area is BH into BF. It is same as that of BH into BI. Okay, BH into BI is the product of two pieces of the chords of a chord. Like that, it is equal to AB into BE, another chord. Okay, AB into B, it is same that of AB into BC. Therefore, area of the initial rectangle is equal to area of the newly drawn rectangle. And so, why their areas are equal? Let us explain it like that. Area of the initial rectangle ABCD is equal to AB into BC. AB into BC is same as that of AB into BE, because BE is drawn equal to BC. Now AB into BE is BH into BI. Let us write that one. Now BH into BI is BH into BF, because BF is drawn as equal to BI. Therefore it is BH into BF. BH into BF is the product of length and breadth of the rectangle BFGH. Therefore this one represents the area of the rectangle BFGH. Now we have got like this: area of rectangle ABCD is equal to area of rectangle BFGH. Now we have drawn a rectangle with the area equal to a given rectangle. I think that you have understood this one. If you have got the idea, pause the video, then write such a question, draw a rectangle here, draw again the same rectangle here, then make the or draw or construct all these things in your notebook as we explained. Then at last write down these much steps there in your notebook. Here, read the question. We are asked to construct a rectangle of sides 5 cm and 3.5 cm. Then we need to draw another rectangle with the same area, but its one side is 6 cm. First, let us draw the rectangle with the sides 5 cm and 3.5 cm using the scale and the protractor like that. We know how it is to be drawn. Now, we need to draw another rectangle. Its one side should be 6 cm. We know how to construct such a rectangle with area equal to this one. We have done already, but here it is specified. It's 1 cm. Its one side is 6 cm. For that 6 cm side can be drawn in any direction from this vertex as we have explained. But better to draw it here by extending this breadth downward, so that we will get some convenience there for the construction. Okay, and so let us extend this breadth outwards. Along that extended line, let us mark the 6 cm as the length of the next rectangle to be drawn. And so let us keep the scale here with this breadth as to make a 6 cm line. See, when we place scale on it, here 6 cm from this much distance up to this one, here 6 cm point is there. We need only to extend this breadth up to this point. Okay, when we draw such a side, now we have drawn the length of the rectangle. Now let us mark its end point like that. See, now we need only to determine this much length should be the length of the next rectangle to be drawn. Now the only thing with us is how much is its breadth. We need to determine its breadth. Now all the activities here we are going to do is to determine its breadth. For this, let us first extend this length of the first rectangle outwards. Let us extend it out. Along that extended line, let us mark the breadth along that extended line. For this, keep compass here. Take this much distance in compass. Then draw an arc with the same distance in compass. Here we will get an arc. That arc meet at a point on that extended line. Okay. Now we need to draw a circle through these 3 points. We need to draw a circle through these 3 points. One point is there here, another point is there here, and a point is the vertex of the triangle. You will understand for what purpose it is. Here we need to draw a circle passing through these 3 vertices. We have explained how it should be drawn. When such a circle is drawn, we see here this much length is a chord of the circle. Then the product of these 2 pieces is the area of this rectangle, because we have made this much distance equal to the breadth of the rectangle. The product of these 2 pieces is the area of this rectangle. We know that product will be same as that of the product of these two pieces. That means this much distance and this much distance when multiplied will be same as that of the product of these two pieces. Therefore, we can draw an equal area rectangle with this much length as its length and this much length as its breadth. And so the only activity with us is to make this one length and this one breadth, then complete the rectangle. And so keep compass here. Take this much distance. Here this one is already 90 degree, and so we need not to make a 90 degree there. This much length should be the breadth of the next rectangle. And when that one is multiplied with this one, we will get the area equal to this one. And so to mark the breadth, keep compass here. Take this much distance in compass. That breadth can be either marked along this way or along this way. Let us mark this much breadth along this way. And so keep compass here. Take this much distance in compass. Draw an arc here. We will get an arc like that. See. Now this one is the breadth of the new rectangle. Now we need only to complete the rectangle by drawing two more length and breadth. Now keep compass here. Take this much distance in compass. Take this much distance in compass. Then keep compass here. Draw an arc here. Then take this much distance in compass. Keep compass here. Then draw an arc there again to cut the first arc. We see this one is the point of intersection, where this one is the last point of the rectangle to be drawn. Then let us join these two sides so that we will get a rectangle there. See, a rectangle is drawn. We argues that this rectangle have the same area as that of this one. That means let us shade the initial rectangle. The area of the initial rectangle, that rectangle, this much area will be equal to this much area. Let us shade that one. See, this much area. These two shaded regions are equal in area. Now we have drawn. This one is 6 centimeter long. This one is its breadth, whatever be that one. And so how their areas are equal, if it is needed, let us explain how. Let us name the initial rectangle by A, B, C, D. See, now the area of the rectangle, let us explain how their areas equal. It is AB into BC. AB into BC is the area of the initial rectangle. Then BC is same as that of this much distance. Therefore, AB into BC can be told. Let us name this point by E like that. Therefore, we can tell AB into BC will be AB into BE then. See, it will be AB into BE. AB into BE will be equal to this much distance into this. For that, let us name these two vertices by F and this one by F and this one by G like that. So that let us tell AB into BE will be equal to BF into BG. It will be BF into BG then. See. Now we have marked this point such that BG is equal to BG and this much distance are same. So that let us name this one by some other point. Let it be some H like that. And therefore we can tell BF into BG will be equal to BF into BH then. It will be BF into BH. BF into BH is length into breadth of the last or second rectangle. And so that one is the area of this rectangle. Let us name the last vertex by I. And so this BF into BG will be area of BFIH. This one will be the area of the rectangle BFIH. And so we have proved area of rectangle ABCD, or we have drawn another rectangle with the one side 6 centimeter. Its area is same as that of the given rectangle. You have to write this question. Then draw or construct all these with the steps, with the method that I have explained. Then at last write down these much steps to tell these two triangles are equal area. pause the video and write down all these things. Now, one textbook problem. See the figure. Read the question. Here, an inclined line from the center to a chord is drawn. Its length is 5 cm and the pieces on the chord are 4 cm and 6 cm. We need to determine its radius of the circle. Okay, let us redraw the figure. See, let us name the chord by AB. See, the chord is named as AB. Now, here this one is an inclined line drawn from the center, and so the center, let us name it by O. Now, where that inclined line meet the circle, let us name it by P, like that. See. Now, to determine radius, let us have some constructions. Here, OP, the line OP can be extended to both direction. As we extend it to both direction, where they meet the circle again, that is 2 points where that extended line meet the circle, let us name it by C and D. Now see the figure. Now two chords AB and CD intersect at the point P. We know when two chords intersect inside a circle, then the product of the pieces are equal. Therefore, in this figure, we see PA into PB. PA into PB equal to PA into PB equal to PC into PD. The product of the pieces of each chords are equal. Okay, we have written then PA into PB equal to PC into PD. Now, PA and PB are known. Let us substitute it by 4 and 6. Now, what about PC? PC means this much distance. PD, P to D. We don't know the radius of the circle. We know the length OP is 5 cm. If we suppose the radius by R, PD will be that R plus 5. PC will be from this much distance we have to subtract this piece. Therefore, PC is equal to R minus 5. Therefore, PD into PC. PD is R plus 5 and PC is R minus 5. From the figure, if we suppose the radius by R, we will get like that. This PD into PC, PD can be substituted by R plus 5 and PC by R minus 5. Therefore, if you write PD and PC at first, it will be R plus 5 into R minus 5 is equal to 4 into 6. See, R plus 5 into R minus 5 will be 4 into 6. It is in the form of A plus B into A minus B. We know it is A square minus B square. In that way, it is R square minus 5 square is equal to 24. R square minus 5 square. It is R square minus 25 equal to 24. Therefore, R square is equal to 25 plus 24 is equal to 49. Therefore, R square of R is 49. Therefore, R will be square root of 49. That is equal to 7. Now, the radius of the circle is 7 cm. You can write the question first, then draw a rough figure like that as I have shown here. Then make all these additional constructions on it. Then write these steps in your notebook to get the radius of the circle. Pause the video and write down all these things. Now, instead of writing the answer like this, let us have one more method. See, we could have answered it in this way also. See. Let us answer it in this way also. See, when we drop a perpendicular from the center O of the circle to the chord AB, if we drop a perpendicular from O to the chord AB, where that perpendicular meet the circle, let us name it by EM. Now see, angle OMP is a 90-degree angle because we have drawn perpendicular. We know the perpendicular from the center to a chord bisects the chord. In that way, since AB is the total length 4 plus 6, we know these two pieces are 4 and 6. Therefore, total length of the chord AB will be 4 plus 6 is equal to 10. As OM bisects AB, MA or AM will be 5 cm then. This much length AM will be 5 cm. We can calculate PM. AP is 4 and AM is 5, therefore PM is equal to 5 minus 4, that's equal to 1 centimeter. PM is now 1 centimeter. Consider triangle OMP. Okay, we have determined PM. We know OP. Let us calculate OM. OM is the altitude of that right triangle. It will be equal to square root of hypotenuse square minus base square. Therefore, OM is equal to root of 5 square minus 1 square. Root of 5 square, 5 square is 25 minus 1 square is 1. Root of 25 minus 1 will be, OM will be root 24 then. OM, this much length will be root 24. We need to determine radius of the circle. Radius means from the center we have to join OB, that is the radius. We need to determine the length of OB. Consider the right triangle OMB. OM is known. What about BM? That also is known because AB is 6 BM, or it is as the AM. BM is 5 centimeter. Now let us calculate OB. OB is the hypotenuse of the right triangle. OMB, hypotenuse square. OB square will be equal to the sum of the squares of the other two. That means OM square plus MB square. OB square equal to OM, we have calculated root 24. Therefore, OM square will be root 24 on squaring, that square root will lose. It will be 24 then. MB is 5. MB square is equal to 5 square. Therefore, this will be 24 plus 5 square is 25. Therefore, 24 plus 25 will be 49. Now, we see OB square. OB is the radius. Therefore, OB square is 49. Therefore, OB or radius will be root 49 is equal to 7 centimeter. In this way also, we have determined the radius of the circle. You can accept any one of these two methods and write down. If you accept this one, draw such a figure there, then explain these things there in your notebook. Now, let us conclude the class. Here are two works to be done yourself as homework. First question asks you to draw a rectangle of sides 4 cm, 3 cm. Then you need to draw another rectangle having the same area, but its one side is 5.5 cm. The second question asks you to solve the problem in the last problem of the page 68 of your textbook. Okay, thanks.